So this is our first video in AP Physics 1 on kinematics, and in physics there are different branches in classical physics, and we're going to be studying some of them. And we're going to start with mechanics, and mechanics has two branches. One is kinematics, which is all about motion, velocity, acceleration, distance, time. And the second one is dynamics, and it's about the forces and the causes of the motion. And then there's going to be thermodynamics and heat, which is AP Physics 2. There's going to be fluid mechanics, which is AP Physics 2. Waves we do in AP Physics 1 and continue in AP Physics 2 with optics and double slit experiment. And then we have electricity and magnetism. And in AP Physics 1, we're going to be only covering electricity, static electricity and circuits, but we're not going to do magnetism. That is AP Physics 2. And the most difficult part the students are saying is usually circular motion, and not as much circular motion as angular motion. And that is all in dynamics. It's the forces acting that cause the object to do rotational motion. So we're gonna start with kinematics or mechanics, which is the study about the motion. And you need to know two quantities that we're going to be looking at: scalar and vectors. Vectors are different from scalars. So if I tell you outside is 72 degrees Fahrenheit, you will not ask me whether it's left, right, or up and down, because you just know it's 72 degrees. But if I tell you I'm driving with 50 miles an hour, in order for you to know where I'm going to be in an hour, 2 or 3, because 50 miles an hour can be in any direction, you will ask me what direction I'm driving, and I'll tell you like to the north or south or east or northeast and so on. And so the scalar quantity is just the magnitude of the vector. And magnitude, I mean, when you look at your speedometer, it shows you how fast you're moving. It doesn't tell you in what direction. So velocity has scalar part in it and it has vector part in it. So in the velocity, you will have scalar part, which is the magnitude of the velocity, like 32 miles an hour. That is magnitude of the velocity. But then what makes vector different is that it also has a direction. So the vector has a direction. It has a magnitude, how strong it is, and it also has a direction, in what direction it's going. So if scalar is only the magnitude, only the number, how long, how big, or how hot. But in velocity, for instance, or force, you will need to know how strong and in what direction. So that's going to be a vector. So one of the vectors that you need to know the difference is in displacement and distance. So the distance is how far you travel. You see two images that you could travel certain distance before you get where you are going. But the displacement is actually the vector. So the displacement is the shortest distance between two objects, and the distance is how you travel to get from one place to another. So you can go all this distance, but if nobody is watching you and all of a sudden sees you in this position and you used to be in this position, then this is displacement. And displacement is going to be, sometimes I think about like misplacement or being misplaced when nobody saw how you got there. So that displacement is a vector and distance is a scalar. So displacement has the magnitude, how far, and in the direction, in what direction you are moving, so you know exactly where the object is at the end. And also in AP Physics, most of the time we don't deal with displacement and distance, but you still need to know the difference between them. In AP Physics and in physics classes, the object usually moves in the same direction, so the distance and displacement can be the same thing. So if an object, let's say like in the yellow box example, an object starts from point A and goes all around, the displacement is 0, but the distance is the sum of all the numbers. So it's 3 and 3 and 5 and 5, which is 16 meters. But then displacement is 0. and distance traveled is 16 meters. And in physics, we're going to be looking at an object travel 16 meters from point A to point B. So you don't have to worry whether it's distance or displacement. It's still going to be 16 meters distance or displacement, because in AP physics, we just move in one direction. Here's another example of distance and displacement. So if you calculate the distance traveled, which is 6 plus 2, 8, plus 3, 11, plus 1, 12, and plus 1, 13. So the distance traveled here is 13 units, but the displacement is this part. So if I want to find out how far is displacement, I need to calculate the hypotenuse of this triangle. So for the displacement, I will have to do c squared is equal to a squared, which is 4, plus b squared, which is 3. And my displacement is going to be 5 units. So another example of a displacement. So when we deal with kinematics again, we're going to be dealing with distance, displacement, you know the difference now, and scalars and vectors. And one of the formulas that you need to know, the first formula that you need to know, is the distance formula. And the distance formula is average velocity times the time. When you see the line on the top of the letter or variable, that means average. So what does mean average? If you have initial velocity, sometimes you see I or initial velocity as v sub 0 or null. So if you have initial velocity and you have the final velocity, and velocity is how fast an object is moving in what direction, correct? So to find the average velocity between two velocities, it's the same as finding an average between two numbers. So you have initial velocity plus the final velocity divided by 2. That's one of the ways to find average velocity. Another way to find average velocity is from the formula. It's the distance or displacement. Displacement, average velocity is going to be displacement over the time. But in our case, because it's going to be moving, an object is going to be moving in the same direction, our displacement distance is going to be the same. So sometimes you will hear me saying distance, but it's the same thing as displacement as long as an object moving in the same direction. So, to find average velocity, what you need to know, and a lot of students get confused at the beginning, is the line means average. Average means it's the sum of the two numbers divided by 2, or it is the displacement over the time. So here's the first example. If you travel, number one, if you travel 50 kilometers to the east and then 20 kilometers to the west, what is your total distance traveled, and what is your displacement? So the total distance in this case is going to be 70 kilometers. So this one is 70 kilometers. And the displacement is going to be 30 kilometers. And because it is east and then to the west, so your displacement from the original point is going to be 30 kilometers, but the displacement is to the east. I skipped a few easy questions in the previous section, but this is about the speed and velocity. So the average speed, as I mentioned when I introduced vectors and scalars, I told you that the average speed is going to be the distance over time, and average velocity is going to be the displacement over time. And you can calculate average velocity, as I showed the formulas earlier. It's delta x, it's the change, delta means change of the distance, x, over change of the time. Sometimes I'll skip the change of the time because time is always changing, over the, and equals to the sum of two velocities, initial, so I, and final divided by 2. So that would be average velocity. And instantaneous velocity is, so at the instant, if you're driving in the car and it shows you the speed, it's a speedometer, which is the speed, not the velocity. But if you had the direction with that speed at that instant, that would be instantaneous velocity. So you can have average velocity. Let's say you left a house and you stop at the gates open, you stop at the light slowed you down, then you sped up from one light to another, then you had another light. So all these stops will eventually add into your average velocity, because you will look at the time it took you to go from one point to another, and then you will calculate the distance you traveled, and that will give you average velocity, but doesn't mean that you were going at that velocity non-stop. You had stops, you had change of the velocity. So instantaneous velocity tells you at that instant what velocity and what speed is and what the direction is. Let's look at the example for number 4. So number 4 says, a car moved 20 kilometers east and then 60 kilometers west in 2 hours. And you have to calculate average velocity and average speed. So if you're calculating average velocity, that's the displacement. So if you move 20 kilometers east and then 60 kilometers west, then the displacement is 40 kilometers. And that took you 2 hours. So that gives you 20 kilometers an hour. And in physics, we will use meters per second. So to convert 20 kilometers an hour, so it's 20 in kilo. I hope you watched the video on physics, scientific notation, and unit conversions. So kilo stands for 1,000, so 20 kilometers, and there are 3,600 seconds in 1 hour. So 3,600 seconds in 1 hour. I'm going to divide by 100 and by 100, my numerator and denominator, and I divide by 2, my numerator and denominator, so that gives me 100 meters, and I have 18. I still can divide by 2 and by 2, so that gives me 50, and on the bottom I have seconds, 50 over 9 meters per second. I just want to go over the conversions if you did not watch that video, but I suggest that you watch that video. So that would be average velocity, and now we only want average speed. So for the average speed, so speed, and I'm gonna place a line on the tom means average, and you have the total distance traveled is 80 kilometers, and the time is 2 hours. So that is 40 kilometers an hour. I also posted physics videos that are in your lessons about the graphs. I hope you watch those all easier questions before you came to watch these ones. I suggest highly. It would be much easier to understand these questions. So here you have position over time. Maybe I'll post the videos in the description of this video so you know where to go if this is too confusing. So you have position over time. It looks like an object went from 2 meters to 12 meters, and it took an object 4.5 seconds. So it went from 0 seconds to 4.5 seconds. So if I want to find the average velocity, I will look at the total distance traveled. So between 2 and 12, they do it exactly. So I would say like 10 meters right here, 10 meters traveled, and it took 4.5 seconds. So wherever that number is. Or if you take exactly numbers the way they give you, so they will say the distance traveled 9.4 and the time is 4.3 seconds. That gives you average velocity. So for the same graph, position over time on the graph on the right, you want to figure out instantaneous velocity at, and it looks like they are checking instantaneous velocity at 3.5 seconds. So if you want to find at what velocity was an object moving at 3.5 seconds, what you have to do is the tangent line. So the line that passes, touches the graph at one point and doesn't cross the graph is called the tangent line. And then you want to find out is the slope of this graph. The slope of this graph is going to tell you the instantaneous velocity. So the slope is change of the or the rise, and the rise is meters. The rise is meters, and the run is in seconds. So you see that the slope gives you velocity meters per second. So your rise over the run will give you the instantaneous velocity at that specific point. If they ask you velocity, instantaneous velocity at a different point, let's say maybe 2.5 seconds. So at 2.5 seconds, you have to do a tangent line at 2.5 seconds. So you would have the graph something like this. And you would say, this is my rise, this is my run. So the slope of this graph will give me instantaneous velocity at 2.5 seconds. So that is instantaneous velocity if you're given position over time graph. So position over time graph, average, you do the distance over time, and instantaneous is the slope of the graph at the point. Now for acceleration. So acceleration is the change of the velocity over the time. If you see, so the average means the line, so average acceleration is going to be equal to the change, the triangle, the delta, means again change of the velocity over the change over the time. So in other words, acceleration is equal to change of the velocity over the time. And it's measured in meters per second squared. So it is meters per second divided by seconds. It is meters per second divided by seconds gives me meters per second squared. So the units of measurements for acceleration is meters per second squared. Let's look at some questions with acceleration. So if the car accelerates from, so initial velocity is given, so number 8. Initial velocity is given 2 meters per second, and the final velocity is 14 meters per second, and the time is given 3 seconds. What's the car's acceleration and what's the distance traveled? So acceleration is change of the velocity over the time, and I always will do this little box for what's given. Usually when the students struggle, eventually some of you can do these type of questions in your head, but some people will continue struggling. So my suggestion is always to write everything that is given and then the formulas. So you have acceleration is change of the velocity over the time. So acceleration is equal to change of the velocity means the final minus initial. So I have final minus initial over the time. So many people sometimes confuse change and average. So change means final minus initial. So acceleration is equal to final is 14 minus initial gives me 12 divided by the time 3 seconds. So acceleration is 4 meters per second squared. And what distance did it travel? The distance is average velocity times the time. And again, what is average? This is where people get confused. Average and change of the velocity. For the average, I have initial plus the final divided by 2 times the time. So the distance is equal to initial is 2, final is 14, divided by 2 times time is 3 seconds. So I have 16 divided by 2 times 3, 24 meters. Let's look at what acceleration means. So if you start with initial velocity of 2 meters per second, and your acceleration is 4 meters per second each second. So each second your velocity increases by 4 meters per second. So in 1 second your velocity is 6 meters per second. In 2 seconds your velocity is 10 meters per second. And in 3 seconds, so 2 seconds, 3 seconds, your velocity is 14 meters per second. And that's what they give you. 14 meters per second is your final velocity. 2 meters per second is your initial velocity. and it took you 3 seconds to get to that velocity. So it took you 3 seconds to get to the new velocity with this given acceleration. So next question is number 9. If an object accelerates from rest, so initial velocity is 0. Again, I'm always going to write down everything that is given, 0. And the final velocity is 16 meters per second. At the acceleration of 2 meters per second squared, how long will it take, and what is the distance that it travels? So you need to know how long it takes to reach this speed, and then what distance did it travel. So if I have 0 meters per second, before we start plugging in the numbers into the formulas, I want you to understand conceptually. So if I have 0 meters per second, how many times do I add 2 meters per second to get to 16 meters per second? And some of you say probably 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. So it's going to take 8 seconds to get to 16 meters per second, because each second you add 2 meters per second. So what you did is this. You said my final velocity was equal to initial velocity, and you added acceleration as many times as seconds. So my final velocity is 16. My initial velocity was 0. My acceleration was 2. And time. So the time is equal to 8 seconds. So you could use this formula because that's how you understand it. Or you could say, okay, acceleration is equal to change of the velocity over the time. Then the time is equal to change of the velocity over acceleration. So the time is equal to velocity changes 16 minus 0. It's the difference between them. And acceleration is 2. Gives me 8 seconds. Now, the next question is, what distance did it travel? So for the distance, I need average velocity times the time. And average means initial plus the final divided by 2 times the time. Initial plus the final is 16 divided by 2, and the time is, we said, 8 seconds. So that looks like it is 64 meters. Here's some average in instantaneous acceleration. So if you have a velocity over time graph, so if you have velocity over time graph, the slope of the graph is going to be acceleration. So if you look for the average acceleration, you take initial velocity, you take final velocity, and the rise over the run is going to be your acceleration. So the acceleration is equal to change of the velocity over the time. Your run is change of the velocity. You start with this velocity, you end with this velocity, right? Like this is the velocities you're looking at. And the time it takes is the horizontal component of it. So that's the average acceleration is, you look at 2 points and you take the slope between those 2 points. If you look for instantaneous acceleration from the velocity over time graph, just the same as before, you have the graph, which is green one. You find the point at this specific time, and you put the slope to that graph, the tangent line to that graph. And the slope of that tangent line is going to give you instantaneous acceleration right at that specific moment. There are more videos related to the graphs, and I will do more in the future after this video. And I will put the links to this video where you can see and practice more the graph questions. And I want to look at the different type of question right here. What is the displacement of the car whose initial velocity is 5 meters per second, acceleration is given, and 2 meters per second squared, and then the time is given. So again, I'm going to write wherever is given. I have initial velocity is 5 meters per second. Acceleration is 2 meters per second squared, and the time is 10 seconds. They ask you for the displacement, so they ask you for the distance traveled, which is average velocity times the time. I don't know the final velocity. To find the final velocity, I'm going to say my initial velocity, I'm going to add acceleration as many seconds as I need to. So my final velocity is equal to initial velocity plus the acceleration times the time. So the final velocity is 55 meters per second. And if I want to find the distance or the displacement traveled, because it's in the same direction, so it's the same thing, it's average velocity. Average means initial plus the final, divided by 2 times the time. So it looks like it's going to be 30 divided by 60 divided by 230 times 10 gives me 300 meters. Here's an interesting question. So what they ask you is to find the car's acceleration is given 10 meters per second, and it started from rest. And so I have acceleration, I have initial velocity, and I have the distance traveled. So acceleration is given 10 meters per second squared. Distance given 180 meters. And initial velocity is given 0 meters per second. They want you to find the final velocity and how long it took. So I'm going to write acceleration is there and the distance is there. So I'm going to write two formulas and then look at them and see what's given. So here they give you acceleration and the distance. I wrote the formulas for acceleration and distance, and also wrote highlighted what is not given, which is the final velocity and the time. So I cannot use the acceleration formula alone because I have two unknowns, and I cannot use distance formula alone because there is two unknowns. There are two unknowns. So what I'm gonna do, I'm gonna solve my acceleration for time. So I have the final velocity minus initial velocity divided by the acceleration. And then I will take this time and place it instead of the time into my distance formula. I'm going to use the substitution method to solve system of two equations. So I have two equations and two unknowns. So I'm going to plug it in, and I have distance is equal to initial velocity plus the final velocity divided by 2 times the final velocity minus initial velocity divided by acceleration. I want you to look at this part right here and see how many of you remember this formula. A minus b, a plus b. What is it equal to? A squared minus b squared. It's the difference of two squares. So instead of writing my numerator this way, I can write it's the final velocity squared minus initial velocity squared divided by 2a. And that is your distance formula with substitution. So if I solve for the final velocity, I get the square root of 2ad plus initial velocity squared. And this formula, my students often call it the DA formula. And you use this DA formula every single time when you have distance and acceleration. So if the distance and acceleration given, you can find the final velocity using the DA formula. But I always ask the students to derive formula because like 65% of AP exam is going to be deriving the formulas. Memorizing the formulas will not help you. A few things change in the problem and then you do not know how to use the formula. So you always want to derive the formula. So I'm going to plug it in and find what my final velocity is equal to. So here I plugged it in and I found that my final velocity is equal to 60 meters per second. And then I have to figure out how long it took. Well, I already solved it for the time. So all I have to do is plug it in and find the time. So here I plugged it in and I have time is equal to 6 seconds. And I'm going to do a few more questions in the different video. This one is running out of time. So there's going to be another video continuing of acceleration and displacement and a few more videos in kinematics, probably like 4 or 5 more. In the descriptions where to find the following videos, I'm going to place in the description of this video. So watch out for the description and for the links to which videos to watch before this one and which videos to watch after this one.